Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Engineering and Technology, SOET, Postgraduate Certificate in Inventory Planning and Warehousing System for Engineers, PGCIPWS MWR 01 Introduction to Inventory Planning and Control. Block-2 Inventory Models. Unit-6 Inventory Costs Concept of Economic Order Quantity, EOQ. 6.1 Introduction. In the previous units we have learned the fundamental theoretical concepts of inventory management and various selective inventory control techniques. In this unit we shall learn how those concepts can be visualized into reality and applied to real-time situations through modeling of inventory situations and associated problems. Objectives. After reading this unit, you should be able to describe various optimization concepts pertaining to inventory. Explain the concept of economic order quantity, EOQ, of inventory. Discuss various factors affecting inventory. Derive the expression for EOQ of simple EOQ model. Develop simple deterministic, for uniform demand, inventory models. Understand EOQ model for non-uniform demand model. Describe the use of simple inventory models in practical situations. 6.2 Inventory Outlook. Inventory is simply a stock of physical assets having economic value, which can be expressed either in the form of material, money, or time, man-hours. Inventory is also known as an idle resource as long as it is not utilized. Inventory may be regarded as those goods which are procured, stored, and used for day-to-day functioning of the organization. This can be in the form of physical resource such as raw materials, semi-finished goods used in the production process, finished products ready for delivery to consumers, human resources such as unutilized labor, or financial resource such as working capital etc. Centuries ago, inventories were viewed as measures of the wealth and power of a country or of an individual. A businessman's or a country's wealth and power were assessed in terms of quintals of wheat, heads of cattle, grams of gold etc. stored in its storehouses. The management of such inventories was an easy affair. In the recent past, inventories viewed as a measure of business failure. Businessmen, therefore, have started to put larger emphasis on the liquidity of assets as inventories, until fast turnover has become a goal to be pursued for its own sake. Nowadays, inventories are viewed as a large potential risk rather than a measure of wealth due to the fast developments and changes in product life. The present concept of inventories has necessitated the use of scientific techniques in the management of inventories known as inventory control. Inventory control is the technique of maintaining stock items at desired levels. In other words, inventory control is the means by which material of the correct quality and quantity is made available as and when it is required with due regard to economy in the storage costs, ordering costs, setup costs, manufacturing costs, purchase, prices and working capital. It is obvious that the quantity if ordered more will result in more interest in addition to unnecessary storage costs including wastage and obsolescence costs etc. On the other hand, if order is placed for less quantity, it becomes insufficient and suffers the production and thence the promises cannot be kept. Therefore, it is essential to determine the right quantity required. This at the same time has to be economical as well. This quantity in the jargon of inventory is called economic order quantity. In inventory modeling, the main objective and foremost function is to determine this optimum quantity, i.e., economic order quantity, EOQ. This concept of EOQ is the prerequisite for understanding the aspects of inventory. 6.3 The jargon of inventory modeling. The following terminology is commonly used in inventory management. Before going into the depth of the subject, it is necessary to understand meaning of the following terms often used in the inventory management. 1. Inventory horizon. The time period over which the inventory level will be controlled is the horizon. This may be finite or infinite depending upon the nature of the demand of the commodity. 2. Demand. Demand is the number of units required per period. The demand is denoted by capital D or small d throughout this course. Since the inventory period or horizon is often taken as 1 year, the demand is discussed most generally as annual demand, the number of units required per year, or annual requirement. Therefore, in this course, the term demand is used with the sense of annual demand, unless otherwise specified. This demand may be either known exactly, or deterministic, or known in terms of probabilities, probabilistic or stochastic, or completely unknown. 3. Lead time. The time interval between placing of an order and its actual arrival in the inventory is termed as lead time and is denoted by lieutenant. Obviously, the longer the lead time, the higher will be the average inventory. Lead time is generally split into two components, namely a. Internal lead time, ILT, or administrative lead time, ALT, i.e., from initiation of procurement action to placing of the order, and b. External lead time, ELT, or delivery lead time, DLT, i.e., from placing the order to delivery of the material. Order cycle. The time period between placements of two successive orders is referred to as a reorder cycle. The reorder may be placed on the basis of two types of inventory review systems, P-system. 6.4 The operating doctrine. In an inventory control situation, two basic decisions are to be taken which are usually referred to as operating doctrine of inventory. These are I. How much to order? E. When to order? To answer these questions, one should be aware of the costs involved and other factors those influence these decisions. 6.5 The inventory costs. Various costs associated with inventory control are often described under the following heads. 1. Setup cost, the cost associated with setting up of the equipment before starting the production is termed as setup cost and is independent of the quantity ordered for production. 2. Order cost, the cost associated with ordering of raw material for production is known as order cost. The setup cost and order cost are used with the same meaning in inventory calculations. However, the difference lies with the inventory environment in which it is used. The setup cost is used in the environment of manufacturing or producing the material stored or consumed, while the order cost is term used for material purchased or procured from an outside supplier. In other words, it can be described with reference to make or buy strategy. Situations, i.e., setup is for make, while order is for buy situation. These costs are often claimed in the following forms: cost for placing order, advertisement cost, tender cost, advance or deposits, auction cost, cost of consumption of stationery and postage, telephone and communication charges, rent for space used by purchase department, cost of infrastructural setting, traveling expenditure, overheads. 3. Procurement cost, the cost of purchasing or producing a unit of item, is often called procurement cost. This cost is more important when discounts are allowed. The same sense as those for setup cost and order cost is used here for two terms under procurement, i.e., production cost and purchase cost. The production cost term is used for make situation while purchase cost is for buy situation. A. Purchase cost, the cost incurred for purchasing the item. It is the core price of the item is known as purchase cost. B. Production cost, the cost incurred for producing or manufacturing or fabricating a product when the item is produced in-house is termed as production cost. 4. Carrying or holding cost, the costs associated with the storage are called carrying or holding cost. These are often found under the following components: rent of warehouse, store, storage space, go down, interest on the money locked up, insurance of stored equipment, financing charges, cost of obsolescence, outdated material, expiry etc. Cost of deterioration, evaporation, rejections and repair cost due to completed shelf life, shrinkage and spoilage, cost of depreciation of material of equipment, cost of production or fabrication. Taxes and penalties, salaries and wages for security staff and stores management, record keeping costs, cost of infrastructure and maintenance overheads. 5. Shortage or stock out cost, the penalty cost for running out of stock, i.e., one item cannot be supplied on the customer's demand. This cost includes the loss of potential profit through sales of items and loss of goodwill, in terms of permanent loss of customers and its associated loss of profit in future sales. 6. Salvage cost or selling price, when the demand for certain commodity is affected by quality stocked, decision problem based on a profit maximization criterion includes the revenue from selling. The above two costs often confuse us. The basic difference is that the shortage cost is incurred due to stock out while salvage cost is due to excess stocking. 7. Cost of system operation and information processing. As stock level changes, someone must update records whether by hand or by computer. Where the inventory levels are not recorded daily, this operating cost is incurred in obtaining accurate physical counts of inventories. These operating costs are more fixed than variable over a wide quantity, volume, range. 6.6 The concept of economic quantity, EOQ. As long as the inventory is not realized into money, it is felt that materials are dead investments, since they block the money and eat away the profits. Hence, the inventory managers will be instructed to maintain just sufficient stocks. It is well-known fact that the higher stocks mean the higher block of money, but on the other side of this coin, under stocks will interrupt production and makes the machines, men idle and hence affects the reputation of the industry for not meeting the demand or not fulfilling the promises. Hence, there is a dire necessity to arriving to a quantity to be stocked that must neither be high nor be low. Therefore, the operating doctrine of inventory, i.e., when and how much to order or stock, depends on how much it costs to the organization. This concept of optimum order quantity, OOQ, or economic order quantity, EOQ, has gained the prominent and significant role in inventory management. The concept of EOQ was first proposed by Ford Wilson Harris in 1913. He made an attempt to draw a trade-off between the order costs and holding costs. We shall now understand this concept. First, let us think of the order costs. Suppose you are going to purchase some notebooks for which you need to spend 100 rupees to order. This will be almost same when you order 1 or 10 or 100. But, here, when you buy 1, you need to spend 100 rupees toward purchase cost. When you buy 10, the purchase cost per unit would be 10 rupees. When you buy 100, purchase cost you spend on each notebook is only Re1, and so on. Thus, we can observe that the unit order cost decreases on increasing quantity but never becomes zero. Why? Thus, it varies hyperbolically but not linearly. Now let us think of carrying or hold cost. In case of carrying cost, the unit cost increases as you go on increasing the quantity in stores. Thus, one can observe and understand easily that the storage cost or the interest lost on procured material varies linearly. So, the carrying cost on the average quantity stored increases with increase of quantity linearly. Graphically, refer Fig 6.4, it can be inferred that the ordering cost per unit decreases hyperbolically with the increased quantity while the unit carrying cost increases linearly with the increase of quantity. Thus, a trade-off between these two can be obtained to find a most economic order quantity, EOQ, often denoted by Q or CO, which shows the most minimum on total cost graph. The normal drawn at EOQ passes through the point of intersection of order cost curve and carrying cost curve, indicating annual ordering cost is equal to annual carrying cost, i.e., OC equals ACC, at EOQ. 6.7 Limitations of EOQ. 1. EOQ often may not allow ordering the exact quantities as per the calculation. Therefore, ordering quantity will be generally the nearest whole number or number packets or units where a packet is a fixed number of pieces that the seller decides for packaging. Say, instead of ordering 11 dozens, the order may be 1 gross. Similarly, if the EOQ is, say 108, and if each pack of this commodity is say 26, then the buyer needs to purchase either 4 or 5 packs. Neither of these is economic, because 4 packs create shortage while 5 packs make over inventory. 2. The EOQ, due to practical situations of transportation, will be modified. Modifying in order to get a better freight rate may differ with EOQ. Sometimes, the saving in freight may be more than compensation the extra holding cost. 3. Simplification of routine, at times, becomes difficult. For instance, instead of 13 times a year, one may order once a month, once in every 4 weeks. Gives 13 orders, while monthly once gives 12 orders. 4. In case of perishable or bulky items with diminishing consumption or for items whose market prices are likely to decline, it may be better to order less than the theoretical order quantity. 5. Seasonal supply factors, market conditions, availability of transport etc. may indicate larger or smaller purchase quantities. In these situations, judgment should be given more weight than calculated values. 6. Liberal discounts or concession freight rates may suggest larger quantities. But the pros and cons of such purchase should be weighted carefully before taking the decision. Otherwise, the EOQ may not be economic anymore. 6.8 Wilson Harris Simple EOQ Model. Assumptions of the simple deterministic model are: demand is known exactly for a given period, usually 1 year. Demand is uniform and constant over a period of time. No limitations are imposed by storing and clerical capacity. The order cost and storage cost is independent of order size. Orders are received instantaneously. Order and delivery quantities are equal. Buffer stock of finished product is independent of order size. Price of raw material is stable. Order costs per order are same irrespective of order size. Setup cost is constant. Rate of production is known. 6.9 Derivation for Economic Order Quantity, EOQ. First, let us define the terms involved in this mathematical expression and the notations. Let county equals ordering cost per order. CC equals carrying cost per unit per year. D equals annual demand or requirement per year. P equals price of item. Q equals ordered quantity per order. Now, 1. Annual order costs, OC. Dot. Total No of order in the year equals total demand of the year upon quality ordered per order equals D upon Q. Total annual orders cost, OC, equals order cost per order x No of orders per year equals C0 x D, Q2. Annual carrying costs, ACC. Average quantity stocked equals max. Quantity min. Quantity, 2, equals Q0, 2 equals Q2. Annual carrying costs equals carrying cost per unit per period times average quantity stocked equals CCQ, 2. Figure 6.5, costs vs quantity, look at the screen. 6.10 EOQ in the case of continuous and non-uniform demand, consumption. Figure 6.10, continuous and non-uniform consumption model. In the above model with usual notations. Look at the screen. 6.11 Summary. In this chapter, the jargon of inventory modeling and different inventory costs are explained in detail. The concept of economic order quantity, EOQ, and its limitations and derivation of Wilson-Harris simple EOQ and EOQ for continuous, non-uniform demand, consumption, is also explained. Thank you for watching. We will see you in the next video with the next chapter.